Okay, so we need to remind ourselves of what these mean, right? So this is integers, 1, 2, 3, 4. It means positive integers, right? And this is rational numbers. So rational numbers are 1/2, 2, right? -3/2, all the negatives too, correct? So is this a subset of this? Yes. I just want to make sure you're kind of tracking with me here. Are the reals that are negative a subset of the rationals? So reals include things like pi that cannot be written as a rational, so this is false. Okay, is it true that if I take the union of this or this, so join these two together, is that equal to the null set? Is the union between these the null set? No, that's false. I think what would be true would be this. If I take the positive integers and intersect it with the negative integers, 0 is not included because 0 is neither a positive or a negative number. So that would be the null set. So this is false. Okay, so if I take the rationals and intersect it with the reals, rationals intersect with the reals, what's in both of these would just be the rationals, right? Because there are reals that can be written as fractions, but there are ones that cannot, but the intersection would be the ones that can be written as a fraction. So this is true. All right. So here's going to get a little bit more challenging. Okay, so a partition. So if I'm going to talk about a partition, and I'm talking about a set of sets, so I have a big set called A, and I have all of these subsets, but if I join all of the subsets together, I get all of A. So let me just draw a picture. So if this was A1, and this was A2, A3, A4, A5, and A6. Okay, so all of these sets together make all of A. And each of the sets are mutually disjoint. There's nothing in common between them, right? There's no intersection, and all of them together make all of A. Okay, so that's called a partition. So that's a big deal. Okay, that's one big definition. So here is another big definition. A power set is all the sets of subsets. We're going to come back and do examples of this, but I just want you to think about this. The power set of A is called P of A, and it's all the sets of subsets. I'll do some examples on the next page, promise. Okay, ordered two tuples. So that's A, B, and C, D, these ordered pairs, we call them two tuples because we can do n tuples, yay, or three tuples or four tuples. They're only equal if A is equal to C and B is equal to D. And so these n tuples are only equal if for each of the i's, right, x of 1 is equal to y sub 1, x of n is equal to y sub n. So the n tuples are equal. Okay, so here's another definition. So Cartesian product, we say A cross B. So what is A cross B? That's the way of saying ordered pairs. So A cross B would give the ordered pairs where the A is in the set A and the B is in the set B. And so if I have an ordered n tuple, then the first entry would be from A1, and I continue on, and the last entry would be in the set A sub n. Okay, so let's go and play with these definitions and with real live examples. So first off, we're letting E, I'm sorry about that, let E be the set of all even integers. Okay, that's what E is equal to. Let O be the set of all odd integers. Okay, is E and O a partition of all the integers? So if I had all the integers, am I allowed to break it up into evens and odds? 0 is the real problem. Is 0 an even or an odd? Yes, 0 is an even because it can be written as 2k, where k is 0, right? So yes, this is true. So evens and odd is a partition of all integers. Okay, so now if I have t be the set of all positive integers and r be the set of all negative integers, is it true that t and r is a partition of all the integers? No, because 0 is not included, right? 0 is in the integers, but it's not in either the evens, or I'm sorry, the positives or the negatives. Okay, so here we go with the power sets. This is kind of challenging. So we want to find the power set, which is all the sets of subsets. So the power set of A. So I'm looking at this set. So let's find, so the way you're going to handwrite power set is like this. Okay, so what's in the power set? In the power set are all the sets of subsets. So the set 1 is a subset of A. The set 2 is the subset of A. The set 1, 2 is a subset of A, and this is always, you're always just going to have to include this. The null set is a subset of the power of the set of A. So I can choose none of those, right? So these are the sets of subsets from the set A. Okay, so let's try another one that's a little more challenging. So I want to find the power sets of A union B. So let's first find A union B. I'm going to put them together. So I'd get 1, 2, and 3, right? I'm not going to write 2 twice. I've included the element 2. So the set A union B includes the elements 1, 2, and 3. All right, so let's go find the power set of A union B. All right, so what do I want? I want to find all the sets of subsets. So I know I'm always going to have the null set, so I'm just going to write that first. I'm going to have the set that includes 1, the set that includes 2, the set that includes 3. Now I'm going to have the sets that include 2 elements. So all the different combinations that contain 2 elements, and then there's one set that contains 3 elements. So 1, 2, 3, 4, 5, 6, 7, 8 elements. So the number of elements in your power sets is always going to be, so the number of elements in the power set of, let's say star, is going to equal to 2 to the number of elements in star. Okay, so is this true? So here I have 3 elements in the star. So is this equal to 2 to the third? Do I have 8 elements in here? 1, 2, 3, 4, 5, 6, 7, 8. Yes. Okay, so let's look at this. So I had 2 elements in here. So this is 2 squared. So there were 4 elements, right? So this kind of help you. So number of elements in the power set of A, it's going to be 2 to the power of how many elements are in the set A.